So let's talk about Istio Mutual TLS or TLS. I'm not going to discuss what TLS is. The full form of TLS is Transport Layer Security. That means that if you want to send data from one application to another, and if you use TLS, the data would be encrypted so that no man in the middle attack can happen. But the point is that if you have to set up TLS on your own, there are a lot of overhead. You have to do a lot of certificate management. You have to create client certificate, server certificate, etc., and then work on it. But when you use Istio, all these things are done for us. Before I proceed, I want to tell you that I'm not going to show you any demo on mutual TLS. Just try it yourself using the documentation. So let's see how mutual TLS or mTLS in Istio works. So this is our Istio service mesh. I have app1, can be a deployment or a pod with an envoy proxy. And let's say I have this another app2 in another deployment and another pod, which also has envoy proxy. So to communicate from app1 to app2, the traffic goes like this. So from app1 to envoy proxy of app1 pod, and then from envoy proxy of app1 pod to envoy proxy of app2 pod, and from envoy proxy here to app2. Now so far what we have done, we have used HTTP to connect from one app to another. So HTTP is non-encrypted. That means the data that we send or receive will be non-encrypted. So Istio by default has this mutual TLS enabled. When you install Istio, it is by default enabled. What happens is that even if you send traffic using curl HTTP, that traffic uses HTTP protocol to go from the application container to the envoy proxy container. But from envoy proxy container, it is transformed into an HTTPS call or SSL over HTTP or TLS over HTTP. So all your traffic is encrypted if you're going from one pod to another. So this is called mutual TLS. Now the thing here that you might have noticed, even though we used curl HTTP, not HTTPS, Istio allowed the traffic and it was automatically transformed to HTTPS. This is called permissive mode. So even if you make a call with HTTP, you are allowed, or Istio will allow that call, but you can change it to strict using an object called peer authentication. There is one more object that is called policy and mesh policy. So we can use any one of these. This is the manifest file for peer authentication object. Now notice that in the metadata, the name is default and this is how it has to be. You cannot change it to anything else. And the namespace is Istio system. So if you want to enable mode mutual TLS, then you have to apply that in the Istio system namespace using peer authentication object. Now in the specification, we have mTLS and the mode has been mentioned as strict. And notice the namespace is Istio system. Now let's say you do not want that. You want to have some of the traffic to be permissive and some of the traffic to be strict. So let's say the namespace that you have been using prod, we want to allow strict mutual TLS mode for that namespace, and rest all other namespaces should be permissive. So you can do that on namespace level also using the same peer authentication object, but instead of namespace Istio system, we mention namespace prod, and spec and mTLS mode is strict. So let's say one more scenario like this, wherein the app is in an Istio service mesh, app2 is in Istio service mesh rather, but app1 is not, it is outside of the cluster. See, and the call will go via envoy proxy. There is no envoy proxy on the client side, meaning app1 traffic from app1 will directly go out of the pod and then hit envoy proxy of app2. As this app1 pod is not maintained or managed by Istio service mesh, there is no envoy proxy. So in that case, the traffic will be HTTP and it will not be automatically transformed to HTTPS. Now in this case, if you enable this namespace to use strict mode mTLS, then this call would fail. We'll have to use HTTPS only. If you allow permissive mode, then of course this call will be successful using curl. And if you use strict mode, you have to use curl HTTPS. But there are some overheads here because you need to have the client certificate available in this app and you have to present the client certificate while making the HTTP call. And if you have strict mode mTLS enabled for this service mesh, or let's say for this namespace, then this curl HTTP call would fail. We can have another scenario like this. You're making a call from app 1 to app 2. App 1 is being managed by an Istio service mesh, but app 2 is not. So if you make a HTTP call, it should be successful because everything will be an HTTP call. Even though you make the Istio service mesh to have strict mode mTLS, as it is not mTLS because it is not between two envoy proxies, this HTTP call would be successful. But let's say you have TLS enabled on this app and then you make HTTP, then it will not be successful because you have to make sure that you provide the client certificate while making the calls. One more thing I want to discuss, that you can enable mutual TLS or mTLS at workload level also, meaning that you can have it at destination rule wise as well. So let's say we have seen this destination rule documentation. Go here, and on the destination rule itself we have this traffic policy. So click on this traffic policy and we have an option called TLS in the traffic policy keyword of the destination rule section. And if you go to TLS section, TLS settings, there are various modes available. TLS mode. So these are the options. You have mode, which provides various TLS modes. Then you have to mention the client certificate, private key, etc. CA certificate. But let's take a look at the TLS mode. We can disable it. That's what we have done so far. We can have simple, and then you have mutual. Now this mutual is different than Istio mutual because we have to present the client certificate for authentication. If you enable Istio mutual, that means mTLS would be used between the applications which are managed by Istio service mesh. Now in case of Istio mutual, the client certificates and server certificates will be generated automatically by Istio. In case of mutual, we have to generate it ourselves. That's what I was saying, that mTLS is different. In case of mTLS, the certificates are generated by ourselves. And if you take any one of the scenarios like this, let's say app 1, app 2, one of them is not in the Istio service mesh, then in that case we can have mutual TLS enabled, but we'll have to present, app 1 will have to present the certificate, client certificate, to app 2, and all these certificates will be created and managed by us. There's one more place. If you go to subset, we have already seen in subset also we have this traffic policy. So click on traffic policy and we have this TLS setting in the subset rule also. So it might happen that we can enable mTLS or TLS mode at subset level also. So go to TLS settings. It is the same TLS setting that I was talking about. So in the mode we can have simple, mutual, Istio mutual, and disable. And then or else you can mention the client certificates, private key, CA certificates, etc. So in case of mutual, we have to mention the client certificate and private key. So here's an example. So these are the certificates in the destination rule wherein we are presenting the client certificate and the private key. So that's all about Istio mTLS. As I said, I'll not show you any demo for this. So finally, the architecture again. Now this architecture will be much more clearer. We have this control plane wherein we have Istio-D, and in the control plane we have various components like Citadel, Galley, and Pilot. Pilot is the main, by the way. When you talk about mTLS or mutual TLS, everything is managed by Citadel. The certificate authority, the authentication policies, everything is maintained by Istio-D. Now this architecture is more of a security, in the context of security. So see here that we have ingress gateway. So this is the data plane. We have proxy, ingress gateway, egress gateway, and we get the traffic from outside, and we can enable mTLS between the envoy proxies in the data plane. And then we have egress gateway, which allows traffic to go out of the service mesh, and this is the entire service mesh which is managed by Istio. So that's all about Istio. As I said, I did not talk about mTLS much, neither did I talk about egress gateway and sidecar traffic management, but should be okay. If I get enough requests, I'll create video for mTLS and egress gateway only. So let me know about it. So this concludes our hardcore Kubernetes part. Thanks for watching.